to finish with this session, let's talk very briefly about searching in Python lists. This is the second way that we will iterate lists, and it's a very also useful type of algorithm where I, as its name indicates, I will search for something in my list, and the structure is always similar. I'm going to start visiting my elements. As a difference with traversals, sometimes I will finish my search halfway through. I don't have to always visit all of them as I have to do necessarily with list traversal, but maybe I will find what I'm looking for, because this is a search, somewhere in between and stop. Okay, for example, I could be searching for negative elements. I would maybe like to know whether or not my list contains any negative elements, and if I did that, I would start at the first element, like in a traversal, see that this is not negative, this is not negative, this is not negative. So I would, like in a traversal, start at the first element, and again I can traverse from the back, but generally start at the first element and then visit the next element and the next element. But as a difference with list traversal, in list search, when I find what I'm looking for, when I get to this element and realize that this one is negative, I don't continue to search. I stop here and notify that I have finished. For this notifying, I have a slightly different general loop setup. Instead of using that for x in my list or using some variation of range, what I do is that I initialize a Boolean value variable, okay, called, let's call it found, and I initialize it to false. So when I begin my loop, I have not found what I'm looking for, okay, and then I iterate all the elements in my list, but I'm going to use a while loop instead of a for loop, and we have seen while loops before. I'm going to have my I variable, which is the index of the list, and I will initialize it at 0. As I was saying before, if I want to initialize it to the length of the list or to -1, I can also do that. And then what I'm going to do is that I'm going to keep iterating while my found variable is false and I has not reached the end, so it's smaller than the length of the list. At each element, I'm going to check a condition. In this case, whether or not my current element is negative. And then I'm going to update my loop variable. Okay, don't forget to do this. If you forget to do this, you will create an infinite loop, because you will start with found false and a value that also is smaller than the length of L. And if you don't update I, you will never exit this loop and you will have to break the execution of the code. Let's see this in the Jupyter notebook. Okay. In this case, we are going to be searching in a list, which we also created randomly, whether or not this list contains 0. Okay. So let's see again what random list was, and it was this one. Okay. And I'm going to have my while loop. As we were saying, I have this Boolean variable that I initialize at false and tells me whether or not I have finished my search. I have my loop variable. Okay. Sorry, I showed you before random in list, but I'm going to be creating a new one here. Okay. And probably yes, and in my results I will print my list, and I'm going to output different things depending on whether I exited this because found became true or because I became equal to the length. Okay. At every iteration I'm going to check whether or not my current element, L of y, I'm iterating using positions now. So I have to access the corresponding position on my list at every occasion, at every element. Okay? If my current element is equal to what I'm looking for, in this case 0, but if I change this to 7, I will have an algorithm that looks for occurrences of number 7 in my list, then I will put found to true, and I will know that I have found what I was looking for at the last position that I was in. And if I don't find this, then I update my loop variable. As I'm always going to enter into one of these in each step of the loop, my loop will undoubtedly finish. Okay, so let's run it. For example, I have generated a random in list, and now I'm looking for it in all the positions. In this case, 0, which was what I'm looking for, was not found in this list, which is correct. If you want to play with this code, you can probably add some print here and follow the trace of execution. Following the trace of execution, let's say, for example, I can just add here checking, and I will convert into a string L of I, which is my current element. Okay, and this will tell me how things are going. Okay, and let's run it again. So as you can see, at each step I have checked -1, 4, 3, -4, -4, 1, 0, -4, 3, and 4. Okay, and in the end I stopped at 0 and checked that 0 was found in this list. Okay, I can even, if I want to follow the trace of execution a little bit in more detail, I can print here not 0. Okay, and let's run it again, and at every iteration it will tell me what it's checking. It will tell me it's not 0, not 0, until I reach 0 and I stop. Okay, and again I found 0 in this list, in this position. These print functions in the middle of the code help me follow the trace of execution and can be very, very helpful when debugging my code. In these lessons, I'm always using code that I have pre-written that I'm sure contains no error, and I'm hopefully not going to make many mistakes, although I might make some. That happens, okay? Whenever you are coding, you will make mistakes. And a long part of coding and an important aspect of learning to program and to code is to be able to find the errors in your code. To do that, I recommend that you read the error that you get, that you check the line that the error is indicating, and when the errors are a little bit more complex and more complicated, then you might want to use these or other debugging techniques about which we will speak at on some other occasions. Okay, so that's it. We have seen that lists are used to store sequences of data. So my data has some position assigned to each of its elements. So it has this structure where I get things in order. We have seen how to create them in Python and access their elements, and remember that lists have negative indices in Python, which is not the case in other programming languages. Okay, we have seen how to slice lists so we can get subsets of them. We can append to lists. We have seen that lists are mutable, so I can change their contents, which is not frequent for many Python data types, but this is an important characteristic of lists. And we have seen that they are iterable and used different ways to iterate them to produce algorithms of traversal, where I visit all the elements in a list doing exactly the same thing to them, and I use that to count the negative values in one list. We have used also traversal to generate random lists of integer using the random function, and then we have seen a second type of loop involving lists, which is a search loop. It always has this structure with a while, with this double condition, one Boolean variable that tells me whether or not I have found what I am looking for, and one loop integer variable that controls that I have not reached the end of the list. Okay,